divided differences. In constructing the finite difference table, so finite difference table means forward or backward difference table. So it is assumed that here the value of x is not equally x is equally spaced. When x is unequally spaced, then we have to using Newton's divided difference formula. Let f of x0, f of x1, f of x2, etc. These are the values of unknown function y equal to f of x, corresponding to the values of x0, x1, x2 up to xn at unequal interval. Then the first order divided difference are defined as follows: f of x0 x1, which is equal to, so first one write f of x1 minus f of x0 whole divided by x1 minus x0. So f of x1 minus f of x0 divided by x1 minus x0. Then f of x1 x2, so it is denoted as f of x2 minus f of x1 whole divided by x2 minus x1. So similarly we can write f of x2 x3 x3 x4 and etc. So this is called first order divided differences. Then second order divided differences, here we have to using three terms x0, x1, x2, and its formula become f of x1 x2 minus f of x0 x1 whole divided by x2 minus x0. Then f of x1 x2 x3, so its formula become f of x2 x3 minus f of x1 x2 whole divided by x3 minus x1. Then similarly write f of x2 x3 x4 and etc. So it is called second order divided differences. So similarly we can write third order divided difference, fourth order divided difference, fifth order divided difference, or nth order divided differences. So these divided differences are arranged in tabular form, and this table is called divided difference table. So here we have to arrange the term as first divided difference, second divided difference, third divided difference, fourth, fifth up to nth divided differences. And we have to use the formula x0 x1 f of x1 x2 f of x2 x3. Second divided difference x0 x1 x2 x1 x2 x3. So similarly third divided difference is f of x0 x1 x2 x3 and etc. Newton's divided difference formula is also called Newton's general interpolation formula, or it is also called Newton's interpolation formula for unequal spaced values of the argument. Then statement: if f of x0, f of x1, f of x2 and so on up to f of xn be the set of values of an unknown function, f of x is equal to y, corresponding to the values of x0, x1, x2 up to xn at an unequal interval. Then Newton's divided difference formula become y is equal to f of x0 plus x minus x0 f of x0 x1 plus x minus x0 x minus x1 f of x0 x1 x2 plus x minus x0 x minus x1 x minus x2 and so on f of x0 x1 x2 x3. So this term will be continuous. So this formula is called Newton's divided difference formula. Now we have to solving examples on Newton's divided difference formula. First example, determine f of x as a polynomial in x for the following data using Newton's divided difference formula. So given table is x equal to -4, -1, 0, 2.5. f of x is 1245, 33, 5, 9, 1335. So now we have to preparing the divided difference table with the help of x and f of x here. So first column is x, second column is y is equal to f of x. So denote these -4, -1, 0, 2, 5 as x0 value, x1 value, x2, x3 and x4. And second row value is denoted as f of x0, f of x1, f of x2, f of x3 up to f of x4. Now calculate f of x0, x1 value. So x0, x1 formula is 33 minus 1245 whole divided by -1 minus of -4, that become +4. So which use -4 not 4. Then f of x1 x2 become 5 minus 33, then whole divided by 0 minus of -1, that become +1. So its value become -28. So similarly calculate f of x3, f of x2, f of x4, f of x3, which gives the first divided difference. Then second divided difference is f of x0, x1, x2. So subtract f of x1, x2 minus f of x0, x1. So that gives -28 minus of -404 whole divided by x2 minus x0, 0 minus of -4, that become +4. So which gives the result as 94. Then similarly calculate f of x1, x2, x3, f of x2, x3, x4. So which is the second divided difference. Then third divided difference is f of x0, x1, x2 and x3. So subtract f of x1, x2, x3 minus f of x0, x1, x2 whole divided by x3 minus x0, x3 minus x0, which gives the -14. Then calculate f of x1, x2, x3, x4, which gives the 13. Then fourth divided difference is f of x0, x1, x2, x3 up to x4. So second term minus first term whole divided by x4 minus x0. 5 minus of 4, that become 3. So now we have to using all these values in Newton's divided difference formula. So substitute these values in this formula, and after simplifying we will get it the fourth power of equation. 3x raised to 4 minus 5x cube plus 6x square minus 14x plus 5. Then second example, given the data, so here they will given the value of x and f of x here. So calculate f of 9 and f of 18 using Newton's divided difference formula. So solution, our first step is preparing the divided difference formula. So write the first column and second column value and calculate f of x0, x1, f of x1, x2, x2, x3 etc. and calculate first divided difference, second divided, third divided up to fourth divided difference. Then use all these values in Newton's divided difference formula. and we'll substituting x value as 9. So put the value of x equal to 9 in the above formula, so which gives the value of f of 9 as 810. Then similarly substitute f of 18 along with the tabular values in the Newton's divided difference formula. So after simplifying, we'll get the value of f of 18 as 6156.